Number 21, we are actually going to skip. We are skipping number 21 because honestly, I never gave you any of those on the homework during the semester, so we're just going to skip that one. Moving on, number 22. Number 22, they want us to solve this logarithmic inequality, and they want us to round to the nearest 10,000th, which means we might get decimals. Let's zoom in. Now, remember, ln is really log base e. So if that helps you out, you might want to rewrite ln as log base e. Now, how do you get rid of a log base e? You're going to have to undo the logarithm by using the inverse of a logarithm, which is an exponent situation. So you're going to raise both sides, 4 and this side, we're going to raise both sides to become powers of base e. So I'm going to write a big giant E right here and a big giant E over there. That cancels out. The x plus 3 comes down. The inequality comes down. And we end up with the e to the 4th on the right side. Okay, so all we need to do now is subtract 3 on both sides. And we are going to do this with the calculator. X is greater than or equal to. With the calculator, you need to do e to the 4th power. Remember, e is an irrational number. It's a crazy long decimal that has no pattern. It's kind of like pi. But there is an e button on the calculator, so you go e to the 4th, hit equal, and then subtract 3 from it. So if you're wondering where the e button is on any calculator, because e is the inverse of ln, you have to look for the ln button. So when you find the ln button, which is right here, you'll notice that right above it is e, right? E to the blank power. So what you need to do to get to that is, if it's that color, you're going to have to hit the shift button first. Hit shift and then ln, and it should pop up the e to the something power. And from there, you should be able to get an answer. So on the calculator, I just did e to the 4th. I got 54.598150003, and it keeps going forever. Obviously, it's ugly. And then I'm going to take away 3 on the calculator from that answer. So 51.59. I want to say 51. Well, actually, it says to round to the nearest 10,000. Okay. So let me show you my answer. So there's my answer, and of course it says 10,000ths. So here's a decimal. This is the tenths, the hundredths, the thousandths, the 10,000ths. So I need to go up to this value, but if I look at the next one, that's a 5, which makes this 1 go up to a 2. So at the end of it all, this one becomes a 2, and you ignore the rest because it specifically asked for 10,000ths. So there's one answer. So again, on any logarithm, you need to go back to the inside of what you're taking the logarithm of. And we know that you can't have a negative inside a logarithm. You can't do log base e of -5, or you can't even do common log of 10, of -10, that is. So you cannot have a negative on the inside. So because of that, we need to take that inside value, x plus 3, and say that it's greater than or equal to 0. Okay, so we take the inside value, x plus 3, and say that it's greater than or equal to 0. Okay, and you subtract 3 on both sides, you will get x is greater than or equal to -3. Okay, so we have these two answers, this guy right here and this other guy right here. And what do we do with those answers? You go to a number line and you test the areas, or you look at their areas and you represent the overlap piece. So if we go to a number line, you have -3 right here, and obviously way on the positive side you have the 51.6 or something like that. Anyways, when we look at the x is greater than or equal to 51.5982, greater than is to the right. So it's going to the right. And if you look at your other one, x is greater than or equal to -3, it's also going to the right. So the overlap piece is only from here going to the right. So the only inequality that you include is the x is greater than or equal to 51.5982, and you do have to go out to the 10,000th decimal place. Now, if for some reason these areas would have been pointing together, then you would have had to have written them as a compound inequality with the x in the middle, -3 on the left, 51.6 on the right. But since this is similar to the final, this is how it's going to end up being on the final, where you represent the overlap piece and it's just one inequality. Number 23, word problem. All right, tourism. At Rosarito Beach, Mexico, the cost of a hotel room has increased 8.3 annually during spring break. What else does it say? If the average hotel room cost $48 in 1980 and this growth continues, what did an average hotel room cost in 2015? And they want you to use that formula, y equals a times 1 plus r to the t. So what you need to first understand is what this formula actually means. A is the initial amount. So y equals initial amount times 1 is 1, plus is plus, r is the rate. Okay, so what kind of rate increase is this having? What's the rate increase? 8.3%, right? Now, you don't want to plug in 8.3 because 8.3%. Now, what you need to do is convert the 8.3% into a decimal so your calculator could actually do it. All right? So the question is, well, first of all, the rate is the percent that you see there, but you want it as a decimal. And how do you do that? You take your 8.3 and you move your decimal over 2 spaces. So 8.3% as a decimal, you have to take that decimal and move it 2 spaces over. So that's going to be 0.0, you got to fill in that spot. 0.083 as a decimal is 8.3%. Does that make sense? So in here, you're going to put 0.083. So we know that A was the initial amount. We know that R is the percent, but you want it as a decimal. And T is obviously time. So what is the time right here? You're going to have to calculate the time as in years. How many years from the initial date to the date that they want? So we're talking about the word problem. If you go back and read it, it gives you an initial cost in what year? 1980, correct? And they want the new price of what year? 2015? Okay, so how many years have gone by? 35 years. So you're going to have to plug in a 35 as an exponent for time because 35 years have gone by from 1980 to 2015. Okay, and you know what? The initial amount, I probably shouldn't have written that. What is the initial amount? How much did it cost back in 1980? $48. So let me do this. Let me just write really big right here. 48. There you go, $48. So all this is going to be done with the calculator. $48 times parentheses 1 plus 0.083, close parentheses to the power of 35. Now, if you're not comfortable typing it all in, you could actually do one step at a time. You know, you start with parentheses first. So you could go 1 plus 0.083, and that will be 1.083. And of course, it's still to the 35th power. So what do we do next, guys? Do we multiply next or do we exponent next? Exponent. All right. So let's actually do this right here on a calculator. So if you do this correctly on a calculator, you should get 16.2928, 0958. Okay. So let me just rewrite the whole thing. We have the $48 that we need to multiply by the answer of 1.083 to the 35th power, and I got 16.292, and that's all right, okay? Anyway, let's now multiply that answer, 16.292 times 48. So just hit times 48 on your calculator, and you will get the ridiculous amount. Okay, this is not true, but yeah, $782.05. That's how much a room at Rosarito cost during spring break in 2017, which is not true. Okay. The reason why this didn't come out true is because I just threw in random numbers. That 8% increase is probably too much. Yeah, definitely too much. Anyways, but that's how you do this problem. There's going to be a very similar problem on the final. Hopefully you guys understand it. Let's move on to number 24, another word problem, another one with percent. It says, suppose you deposit $100 in an account paying 2% annual interest, compounded continuously, whatever with all that. They tell you to use this formula, okay? So what does the formula mean? So I scribbled in some notes here to help you understand. A is going to be the answer, your total amount after whatever problem you figure it out, right? That's going to be your answer. P is the principal, which is a starting amount, the initial amount. So if they say you started with $100, you're going to type in the 100 right here in the place of P. E is simply the E button. R is going to be, as a power, the rate, but you don't want it as a percent, you want it as a decimal. So you're going to put the power of R on the E, and times time, T is time. Okay, so I hope we understand how to use this formula now. So let's go back to the actual numbers. So what's your initial amount, your principal? How much are you starting with? $100, $100 bill. Okay, so you go to the bank, you put that in there in the savings account. They tell you they're going to pay you an average of 2%. So this is the rate, correct? But you don't want to, well, first of all, it's A times E. So E is simply going to be the E button on the calculator. Now, on the exponent position, you're going to put the rate times time. But the rate, you don't want it as 2, you want it as a decimal. So what's the decimal going to be representing that 2%? 0.02, exactly. That's 2% right there. 0.02 is 2%. Now, how about the time? We'll write that in blue. Times what?
12.
Times 12 years. That's right. Okay, so you could type all this into your calculator, or you could do one piece at a time. I would go with the one piece at a time. 0.02 times 12. 0.02 on a calculator times 12. That gives you 0.24. So we really have 100 times e to the 0.24 power. Okay, so we're going to do the e to the 0.24 power next. Or you could type it all. Let me try typing it all on the calculator. 100 times second ln, that gives you the E button, and it also raises it up to the power. 0.24, but close parenthesis, hit equal, and it'll give you your final answer. Final answer is, if you actually work it all out, the final answer is 127.1249. Okay? So that's really just final answer of $127.12. So if you put $100 into a bank account, that gives you 2% interest. After 12 years, you'll make a whopping $27.12. That does sound realistic. Okay. Looking at number 25, also round to the 10,000ths. Usually those instructions mean that you're going to be using a calculator. So let's start solving for x. So how do you solve for x? You've got to isolate the x by itself on one side. Let's get rid of this 5 by subtracting 5. You're going to get 2e to the 7x equals 23. And then after that, of course, we're going to divide by 2 to get the e by itself. But that's not really the variable that we want to have completely isolated. It's the 7x. So I want to isolate the e to the 7x so I could later get rid of the e by applying a logarithm. But anyways, this is what we have right now. E to the 7x equals 23 divided by 2. If you wanted to write that as 11.5, go for it. It doesn't really matter. You're going to use a calculator anyway. Okay? So anyway, why not? Let's just change this to an 11.5. Okay? Scratch that out. We have an 11.5. So you have e to the 7x equals 11.5. We need to get this x down from the exponent to be a regular term, so you don't want this base e. So what you're going to have to do is apply a log base e, which is really an ln. Log base e is ln. And what you do to one side, you do to the other side. Let me change the thickness of the pen here. We're going to do ln of this side also. Okay? So anyway, the ln of e cancels out. We now have a nice, beautiful 7x. We have an equal sign. And we have 11, or ln of 11.5. Final step would be to divide by 7, And ladies and gentlemen, you do all this on a calculator, right? All this on a calculator. ln of 11.5, hit equal. That'll give you a decimal answer. And then divided by 7, that'll give you your final answer. And they want to the nearest 10,000s. This is tenths, this hundredths, thousandths, 10,000s. So we ignore the 0.6 at the very end. This is your final answer right there.